Guys, welcome to Colossus mathematics class. Don't forget to subscribe, like, and share this video. Alright, today we'll be talking about singular points. Now, when is a point said to be singular? A point is said to be singular when f of z fails to be analytic. These are the keywords there. When f of z fails to be what? Analytic. Now, when is a point said to be analytic? A point is said to be analytic if it is continuous and differentiable. So if f of z fails to be continuous and differentiable, then you say f of z is a singular point. Do we get that now? Alright, so let's talk about types of singular point. Now the first type of singular point that we need to know is the one we call the isolated singular point. Now, when is a point said to be isolated? So you see the point z equals to z naught is said to be a singular point if delta greater than 0 such that the absolute value of z minus z naught is less than delta. Now, this is when you say a point is an isolated singular point. So if we have the point, if you have delta greater than 0 such that the absolute value of z minus z naught is less than what? Delta, then you say what? The point is an isolated singular point. Now, if we can't find delta, if there is no delta, if there is no delta greater than 0, I get what I'm saying. If there is no delta greater than 0, then z minus z naught less than delta is a non-isolated singularity. Do you get that now? So, here we said if there is delta such that the absolute value of z minus z naught is what? Is less than delta, then we say what? It is a what? It is an isolated singular point. But if there is no delta greater than what? 0, then it is no longer a what? An isolated point. It is a what? A non-isolated point. And if this is a non-isolated singularity, now what do we even mean by non-isolated singularity? This point z naught is what we mean by the isolated singularity. Don't forget we said the point z equals what? Z naught. So this z naught is said to be a point of what? Isolated singularity. Here, if we have this such that this is less than this, then this z naught is what? Is called an isolated singularity. But if there is no delta greater than 0, then this point z naught is what? Is called what? A non-isolated what? Singularity. Now, if z naught is a non-isolated singularity, if z naught is a non-isolated singularity, don't worry, the word singularity and singular points are the same. Now, if z naught is a non-isolated singularity, we said when it's a non-isolated singularity, it means that what? There is no what? There is no delta naught. But now, if z naught is a non-isolated singularity and we can find delta greater than 0. Now, we said it is a non-isolated singularity if we cannot find this thing. Now, if it is not if z naught is now a non-isolated singularity and we can now find delta greater than 0, then we say if we can find the point delta greater than 0 such that what? The absolute value of what? Z minus what? Z naught is less than what? Delta. Then the point z0 is called an ordinary an ordinary singular is called an ordinary singular point. So the three things you have to note in this thing is, we said if the point z equals to z naught, if delta greater than 0 such that z minus z naught is greater than delta, then the point is said to be what? An isolated singular point. But if there is no delta greater than 0, then the absolute value of z minus z naught is what? Is a non-isolated what? Singularity. That is if there is no delta greater than 0. But now if this z is a non-isolated singularity and we can now find delta greater than 0 such that the absolute value of z minus z naught is greater than delta, I mean less than delta, then you call the point what? An ordinary singular point. So do we get that now? So that is under the first type of isolated singular point, which is under the type of singular point. So the second one before we wrap up for today, is what we call poles. So pole, the second one is pole. Now, when do we call a number a pole of order whatever? You say, the time you say a number is a pole of order anything is when you can find a positive n integers. When you can find a positive n integers such that, so this is the such that this is the formula we use when we are solving pole. So such that the limit as z tends to z naught of z minus z naught raised to power n multiplied by f of z equals to a and not equals to what? 0. That is the limit of this z minus z naught as your z tends to 0 should not multiply by your f of z, which you will be given in the question, should give you a particular number and not 0. Do we get that now? All right. So if this occur, if it is giving us a and not 0, then z equals to z naught is called a pole of order n. So if z equals to z naught, if this is giving us a number and not 0, then you call z equals to z naught a pole of what? Of order n. Now if n equals 1, then z equals z naught is a simple pole. So if n equals 1, z equals z naught is a simple pole. If n equals 2, then z equals to z naught is a pole of order 2. And if it is 3, if n is 3, then z equals to z naught is a pole of what? Order 3, and it goes on and on like that. Alright, so let's see an example under that before we wrap up this class. So don't forget, this is the major formula that we use under pole. Alright, still under pole. So let's see an example still under pole. Let's say f of z equals to 1 over z minus 2 all square. If I have this particular question and I'm told to find the order, how will you do it? Don't forget the formula is what? Limit as z tends to what? Z naught of what? Z minus z naught all raised power n multiplied by what? F of what? F of z. Now from here, we said z minus z naught. So So if you look at this, you see we have z minus what? 2. We have z minus 2. That means automatically my z naught is what? Is 2. So it will now become limit as z tends to what? What's my z naught now? My z naught is what? 2. I get what I'm saying now? Of z minus what? 2 raised to power n. This is your n, which is what? 2. Abi, multiply by what? F of z. What's the f of z? 1 over z minus what? 2. All raised by what? 2. And now you can see from here that this will cancel this, right? And you'll be left with what? Limit as z tends to what? To 2 of what? 1. And the limit of a constant will give you what? That constant. And that means this is equal to what? 1. That means this f of z is a what? Is a pole of order what? Order 2. Do we get that now? Because it is giving us a real number and that is not equal to what? 0. Do we get that? Alright, let's see the last example for today. Okay, so let's say we have f of z equals to 3z minus 2 over z plus 1 all square then z minus 1. Now, if I have this particular question, how are you going to solve it? It is very simple. The way you solve it is that you first solve for this, then you solve for this. So don't forget our formula is what? Limit as z tends to what? Z naught of z minus z naught raised to power n multiplied by what? F of what? F of z. Now, this is the first one you are going to use. And now if you look at this, you see that from here, your z naught will be equal to what? Minus 1. Because it is only when your z naught is equal to minus 1 that we make this equation undefined. If you look at this, it is when your z is equal to what? 2 that it will make it what? Undefined. Are you get what I'm saying now? Alright. So let's run through this. Our z naught is what? Minus 1. So that will have what? Limit as z tends to what? Z naught of z minus, z plus minus 1, because our z naught is what? Minus 1. You can see from the formula it is minus z naught and our z naught is what? Minus 1. So that's why I have to put it in bracket. Then close the bracket, multiply by f of z. Our f of z is what? 3z minus what? 2 over z plus 1 all square. Don't forget this one too, we have square because of this. All square, then z minus 1. Do we get that now? Alright. So after this, you can see that this is going to cancel because this minus and minus will give us plus, and it will also cancel this. So we have limit as z tends to, our z naught is what? Minus 1. So anywhere 3z minus 2 over z minus 1. So after that, the next thing you do is that you put minus 1 in anywhere you are seeing z. So that will now be 3 open bracket minus 1 minus 2 all over minus 1 minus 1 minus 1. And that will now be 3 times minus 1 is minus 3 minus 2 over minus 2, and that what? Minus 5 over minus 2, and that's 5 over what? Over 2. Now you can see that it is giving us a number and not 0. So since it is giving us a number and not 0, then you see f of and our z naught is a what? Is a pole of order what? Order 2. I guess what I'm saying. It is a pole of order 2. So the same way I did this is the same way you are going to solve for the second one. So your z naught in the second place will be what? Will be 1, and you use it like this, like I did in this particular side, and you will be able to get the answer for that. So that is all on poles and singular points. So in the next class, we'll continue on types of singular points. So don't forget to subscribe, like, and share the video.